In this problem, we have two runners with different velocities who have a combined momentum of 350 kilogram meters per second when they are running. There are two different scenarios to describe their motion. They can be running in opposite directions or in the same direction. If they are traveling in opposite directions, then one of the velocities must be negative. If they are going in the same direction, both velocities will be positive. Let's look at the option of both runners going in opposite directions first. Here's the given information for the two runners. The 60 kilogram runner is going in the positive direction with an unknown velocity, and the 70 kilogram runner is traveling with a velocity of negative 2 meters per second. Their total momentum equals 350 kilogram meters per second. We want to start with the equation to find the net momentum of the runners. The sum of the momentums equals momentum 1 plus momentum 2. Since in this case runner 2 is going to the left, the momentum is negative, making our equation the sum of P equals P1 minus P2. Because our goal is to solve for V1, we should rearrange the equation to isolate P1. We can rewrite P2 as M2 times V2, and now we can plug in our known values. We can solve for P1. P1 equals 490 kilogram meters per second. This value can now be used to find the velocity of the 60 kilogram mass. The equation to solve for momentum will allow us to find V1 if we rearrange it by dividing both sides by the mass. We are ready to plug in our values, and now we can solve for V1. V1 equals 8.2 meters per second when the 70 kilogram mass and the 60 kilogram mass are running in opposite directions. Now the velocity for the 60 kilogram mass must be found when they are running in the same direction. Our given value for the net momentum remains the same. The only thing that changes is the direction of V2. It is now in the same direction as V1, making it positive. We solve this part exactly the same as we did the first part. The only difference being that P2 is positive. We need to isolate P1. We can now change P2 into its equivalent, M2 times V2, plug in the values, and solve for P1. P1 equals 210 kilogram meters per second. Now we want to use our momentum equation to find V1. Rearrange the equation to solve for V1, plug in our values for P1 and the mass, and solve for V1. V1 equals 3.5 meters per second in the same direction as V2.